Hello everyone, welcome to new class. Today's class is the continuation of operational amplifiers. So let us study about the open loop configurations of op-amp. Open loop means there is no feedback, and this is the simplest possible way to use an op-amp. Since the gain is very large, gain is very large in an open loop condition, the output voltage V0 is either at its positive saturation voltage plus Vsat or negative saturation voltage minus Vsat as V1 is greater than V2 or V2 is greater than V1 respectively. So here the output voltage is either plus Vsat or minus Vsat, and this is the simplest possible way to use an op-amp. And there are three configurations, that are differential amplifier, then inverting amplifier, and non-inverting amplifier. So these are the three configurations of, that is, open loop configurations of op-amp: differential amplifier, inverting amplifier, and non-inverting amplifier. Let us study about these configurations in detail. First one is open loop differential amplifier. So this is the circuit diagram for the open loop differential amplifier. Here the inputs are applied to both inverting and non-inverting input terminals of the op-amp, and the device amplifies the difference between the input voltages. The input voltages are V1 and V2. The source resistances are R1 and R2. And the source resistances R1 and R2 are very small compared to the high input resistance of op-amp. So, neglecting the voltage drop across the source resistances, we have V0 is equal to A into V1 minus V2. V1 is the non-inverting input terminal. So, A into V1 minus V2 is the output voltage V0. And A is called the open loop gain or large signal voltage gain. So this is the open loop differential amplifier. Next open loop configuration is inverting amplifier. So this is the diagram for the inverting amplifier. In this, the input signal is applied to the inverting input terminal of the op-amp, and the non-inverting input terminal is connected to the ground. So the output voltage is 180-degree out of phase with respect to the input, because it is connected to the inverting terminal. So the output voltage V0 is equal to A into V1 minus V2, and that is equal to A into V1 is 0. So A into minus V2, that is minus A into V2 is the output voltage. So the output voltage is 180-degree out of phase with respect to the input, and the input signal is amplified by gain A. So input signal is amplified by gain A and is phase shifted by 180 degree. So this is the input signal. So what will be the output signal? The output signal is 180 degree out of phase with the input signal. So and also amplified. So it will be amplified and 180 degree out of phase. But here in open loop configuration, we will get the output as at plus VSAT and minus VSAT only. So the output waveform will be like this. That is, it will be at minus VSAT and also at plus VSAT. This is the output waveform for the inverting amplifier. That is open loop inverting amplifier. Here it will be between plus VSAT and minus VSAT. And also remember one thing, that this plus VSAT will be less than the positive biasing voltage, that is plus VCC, and also negative VSAT will be always less than the negative bias voltage minus VEE. So this is inverting amplifier. Next open loop configuration is non-inverting amplifier. So this is the diagram for the non-inverting amplifier. In this, the input signal is applied to the non-inverting input terminal of the op-amp and the inverting input terminal is connected to the ground. The input signal is amplified by gain A and the output is in phase with the input signal. That is V0, output voltage V0 is equal to A into V1 minus V2, and here V2 is equal to 0. So we get A into V1. That is, the input signal is amplified by the gain A and hence the output is in phase with the input signal because it is applied to the non-inverting input terminal. And here what will be the input and output waveforms? So let this be the input waveform. Then it will be amplified by the gain A. So it will be amplified and also it is in phase. So it is amplified and in phase with the input signal. But here also this is open loop configuration. Here also the output waveform is between the positive saturation and negative saturation. So it will be between plus VSAT and minus VSAT. So this is the output waveform for the non-inverting amplifier. Here the output is in phase with the input signal and amplified version of the input signal. So that is about the three open loop configurations of op-amps. Now let us discuss about the disadvantages of this open loop configurations. So next is disadvantages of open loop configurations of op-amp. So when an op-amp is operated in open loop configuration, the output either goes to positive saturation or negative saturation or switches between positive and negative saturation. That is, if the input is like this, output will be the amplified version, but it clips the output. So it clips the output above the saturation levels. So it clips the output above the saturation levels. So the open loop configuration cannot be used for linear applications. Cannot be used for linear applications. So the open loop configuration of op-amp cannot be used for linear applications, but it can be used for non-linear applications like square wave generation. Square wave generation. So used for square wave generation. So these are the disadvantages of open loop configuration. So the main disadvantage is it cannot be used for the linear applications because it clips the output above the saturation levels of the op-amp, that is the bias voltage levels of the op-amp. So that is the main disadvantage of the open loop configuration of the op-amp, but it can be used for the non-linear applications like square wave generations. So that is about the open loop configurations of op-amp. In the next class, let us discuss about the closed loop configuration of op-amp. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.